see both of them. So we're going to see more than one notation. This is one of them, though, and it's probably the easier one. The other notation's a little weird. I don't know. But it's mostly because there's calculus was, some people might know, was, does anyone know who created calculus? Anyone?
I think Ryan knows.
Ryan, what do you think it is? Isaac Newton was one of the people who created calculus. He was, I don't know, he was in his 20s, I think, but maybe 18, maybe when he started. Now, the interesting thing about calculus is a lot of people just think Isaac Newton created it, which is kind of true, he did, but it was simultaneously also come up with by a man named Leibniz, who came up with it at the same time in a different place. And so there's two different notations that gets used because Newton and Leibniz both did it at the same time. The notation that we use more frequently, I actually think, is Leibniz's notation. Isaac Newton, I don't even think he came up with a notation, to be honest, because it was sort of like Isaac Newton was a real jerk about it. He came up with calculus, and he didn't want anyone to understand it. He thought it was like really valuable information. He did not make it easy for people to understand. Whereas Leibniz worked really hard to make sure that people could understand calculus and came up with a clearer notation. But anyway, this is one of the notations. And that's just like some factoids for you. So instead of talking about the slope of a tangent line, we're going to talk about the derivative, which is the same thing. Okay, so don't let it confuse you. It's just a new symbol. So here, if we were told, okay, then it's just the same formula there. But if we were asked to differentiate f of x equals x cubed, all we're doing now that's different from last unit, the only way it's different is we are not being given a value for a. Like there's no at x equals 3. Okay, that's not there. So what you're doing is you're not plugging anything in for a, or in this case x, because we're going to start just using the formula with x. So I'm using that formula up here, and I'm just filling it in. So I have the limit, I have f prime of x is equal to the limit of h approaches 0, and it's of f of x plus h, so that's x plus h cubed, minus f of x, so minus x cubed, over h. So you'll notice there's no number in there for x. That's the only difference between this and what we were doing before. And in fact, there are a couple people in the room who have been doing the equations this way anyway, and then plugging a in at the end. So if you're doing that, it'll give you kind of a leg up, because this will be simpler. Now, I would probably do x plus h cubed somewhere else. If it was me doing this myself, I'd probably like go over on the side and do x plus h cubed somewhere, because x plus h cubed, right, is long. So I would probably do it somewhere else. I'm like, okay, that's x squared plus 2xh plus h squared. And then if I multiply that by x plus h, I get x cubed plus 2x squared h plus x squared h. So it's going to be 3x squared h plus xh squared plus 2xh squared. So it's going to be 3x squared xh squared. And then plus h cubed. Okay, I believe that's what it's going to be. But I would do that somewhere else if I was doing this problem on my own. So just so that I don't have to have it in there, like getting in the way of my work. So that's x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed over h. So the x's cancel, x cubes canceled, and then what am I able to do? Take out an h. So you should always be able to take out an h. If you can't, you did it wrong. Okay, that's all it comes down to. So if you cannot take out an h, it's because you messed up. So the h's cancel, and I plug 0 in for h. Now when I plug 0 in for h, what am I going to have left there? 3x squared. Which means the derivative of x cubed, f prime of x, is 3x squared. Okay? So that's it. That's the derivative. We found it. We did it. We were great at it. So now, this is just like the last unit, except you don't have a value for a. If you were given a value for a, if I was like, hey, find the derivative at 3, you could just plug in 3 into that number. So it would be 3 times 3 squared, it would be 27. Okay, or find it at -1, you just plug -1 into that, you would get the value there. So what this is that graph of x cubed, something like that, right? Okay, this equation will give us the slope of the tangent line anywhere on this graph. So if I plug in 0, it's going to give me the tangent line right at, and this graph's not very well drawn, but it would give me the tangent line right at 0. If I put a value in that's over here, give me the tangent line there, it would give me the tangent line here, give me the tangent line here, like everywhere. Okay, so anywhere, any value I plug in is going to give me the slope of the tangent line at that point on my graph. Okay, that's what the derivative is. Okay, so it's exactly the same, there's just no value in for a. Okay, so let's look at a couple, limits problems. Okay, so here's one. This is a limits question that could be on the test. Which statement is true about the curve y equals 2x squared plus 4 over 2 plus 7x minus 4x squared? Okay, take a minute to look at it and come up with what you think is the answer. Okay, so try it yourself. Just see if you can come up with an answer to this. Hey, does anyone think they know the answer? Okay, so there's two separate things here. There's vertical asymptotes and horizontal asymptotes, and they're totally different. So what would the vertical asymptotes of this equation be? I did the work up here for you. I factored things, which is what you should have done, by the way, if you're looking for vertical asymptotes. Where would this graph, if the bottom factors to negative 4x plus 1x minus 2, and the top factors to 2x squared plus 2, what would the vertical asymptotes be? There are two of them. Two is one of them. And negative a quarter, but yeah. Negative a quarter from this one. Okay? So since nothing cancels, since when I factor that, nothing cancels, both of the non-permissibles are going to be vertical asymptotes. If a factor does cancel, what does that non-permissible become? What is it in the graph? A hole, a removable discontinuity. Okay, so I can see that these answers A and B are both wrong. Okay, because the vertical asymptotes are not negative a half or 1. So they're both wrong. Now, I would expect some people to just pick D because it has the number 2 in it, which is one of the numbers we found. But horizontal asymptotes are done totally differently than vertical asymptotes. Does anyone remember how you do a horizontal asymptote, what you look at? Okay, so a horizontal asymptote is what the graph is doing at the end. Okay, like as it continues to move right, it's what the graph is doing. That's what a horizontal asymptote is. Okay, so for instance, right, like if I have the graph 1 over x, which is just like this, it has a horizontal asymptote at 0 because as this goes to the right, it's getting closer and closer to 0. So the way you find horizontal asymptotes, and this is a really important thing, and it's something that we forget because we don't look at it that often, horizontal asymptotes are found by looking at the limit as x approaches infinity. Okay, that's what a horizontal asymptote is. So I'm looking at the limit of that as x is approaching infinity. So if I'm looking at a limit as x approaches infinity, what am I looking at on? So I would expect there to also be a bunch of mistakes. I feel like a lot of people would just look at the front numbers, so it's 2 and 2 here, right at the front. But that's not the way you should look at it. You should look at the highest degree on both the top and the bottom. They have the same degree, so you just take the coefficients. So it's 2 over negative 4, which is negative a half. So the answer is C. Okay, that's how you should do it. If the degree was bigger on top, what would that mean? It would be infinity, and if it was bigger on the bottom? 0. So this is a fairly typical question. Really, it's just testing your ability to take limits as x approaches infinity, but you need to recognize that a horizontal asymptote means take the limit as x approaches infinity. Okay, so you have to recognize that that's what it wants you to do. Otherwise, you wouldn't get this question right. Okay, so let's look at another one. You're going to have questions like this on your test. Okay, now this is looks really simple. I'm sure this would be like one of those like heartbreaking things for people. Okay, but it's actually a really hard question. Lauren says she guesses 1.
That's what I guessed.
That's what
It's A or B.
It's A or B. It's got to be. It's one or the other. Okay. So let's kind of think, does anyone have an idea of how you would even start this one?
You factor the bottom?
You could. I wouldn't, though, to be honest.
Would you do sandwich theorem or no?
Nope, it won't work.
You plug in 0 for x.
You plug in 0 for x, you're going to get 0 over 0.
You skip to the next question.
You come back to it later, just guess. Okay? So this question actually, when there's sine x involved, usually it's going to come back to the fact that we know that the limit of x approaches 0 of sine x over x is 1. It all comes back to that, and you're supposed to be using that fact here. The way you would do this one is actually to split this up. Oh, actually, no, you can't split it up, can you? Oh, so maybe, actually, you know what? Conrad was right. Factor the bottom. Conrad's the best. He's the winner of the class. Okay? Because we want to split this into something where I would actually have sine x over x. Now, the cool thing about this is once I factor it, like Conrad suggested, the ever wise, okay, we have this here, sine x over x. Okay? So I could actually write this if I wanted to, instead of writing it, I keep putting h's, I'm so used to it. Instead of putting sine x over x, x plus 3, I could write this as sine x over x times 1 over x plus 3. Okay, because that's the same. Now, sine x over x is 1, and 1 over x plus 3, if I plug in 0, is what? 1 over 3. So the answer is B, 1 over 3. Cyrus was right. It was either A or B. So this one is a tricky problem because it involves that. But it's if you are looking at something where you have a sine x and it's x approaches 0, what you should be trying to do, and they're all different. And even like just now I thought of it the wrong way. I thought of doing something and then I realized it wouldn't work. But the point, like what you're always wanting to try to get is sine x over x somewhere. Okay? Or if you have sine 5x, you want to get 5x on the bottom. Because then you'd have sine 5x over 5x, which is also 1. Okay, so anytime these are involved, they'd always be multiple choice questions pretty much. And it would be a matter of trying to figure out how you can get sine x over x somewhere in the equation. They're tough problems, though. Okay, without. Okay, so that's how you do it, though. So it's good to look at. Okay, let's look at another derivative. This is the alternative derivative formula. It's the same. Okay, but now we have x. We've looked at this one before too, but let's just see how it works. Okay, this gets used much less often, but let's try it out. So if I was trying to do this, I would say f prime of a is equal to, and now it's f of x, so that's just root x. Oh, sorry, it's not f of x yet, is it? It's the limit as x approaches a of f of x, which is root x. What would I write for f of a? Root a, thank you. Okay, over x minus a. Okay, is absolutely correct. That is what you would write. Okay, so now f of a really just means a put in where x was, right? That's what it means. So now I have this. Now how would you suppose I would compute a limit like this? There's radicals in it. So what should I do? Rationalize. I should use conjugates. So what will I multiply by?
Root x plus root a.
Root x plus root a. That is not the same as root x plus a, like with one root, just to be clear, because last time there were some problems with that. Now when you multiply it, on top you get x minus a, and on the bottom, what should you not do? Aiden? Don't expand it. You get x minus a times root x plus root a. The reason you do not expand it is because, as you can see, they cancel. If you expand it, you will not be able to see that they cancel, and you will get the question wrong. So these cancel, leaving you with 1 over x, root x plus root a. Now what should I do? Because I'm at kind of a weird point now. There's no number to plug in. There's no 0. It's not x approaches 0. It's x approaches a. So what should I do? Plug a into x. So I end up with 1 over root a plus root a. This is very similar to one that was on the quiz. What is root a plus root a? 2 root a. It certainly isn't root a squared or root double a or anything like that. Because on the assignment, on the quiz, it was root 5 plus root 5, and I got a lot of root 10s, which is incorrect. So that would be the answer here, is 1 over 2 root a. Okay? And that's it. So again, this is an equation for the tangent line any point on the graph of root x. So the graph of root x looks like this. This is just an equation that could give you the slope of the tangent line anywhere along it. And as we go higher and higher with x values, the slope is going to get flatter and flatter. Does that make sense? Because this graph, it starts off kind of steep, it's like going up, and then it kind of just tapers off and it's like really flat. Like if you were walking up a hill, it would be really flat at the top. And you're just continuing to go up, but only like a slight amount. So your slope is getting less and less steep. That's why if we plug higher and higher numbers into a, this number, 1 over 2 root a, is going to get smaller. It's going to get closer and closer to 0. Like if I plug in 10, or sorry, if I plug in 100, I'd get 2 times root 100, which is 20, so 1 over 20, which is really close to 0. Okay, we can see that the slope is flattening out based on this. It's pretty straightforward, I think. I don't know. It's really similar to what you were doing. That's kind of the point I want you to get from it. We're going to take a look at some of these later. We're just going to look at a couple more multiple choice questions, but I do want to show you the derivative notation. So there's a whole bunch of different notations. These are a whole bunch of them here. So f prime, I mean, there's kind of 2 different ones though. I hope you can see here where the split is. It's like these 3 and these 3, they kind of go together. So the first 3, you can see there's f prime of x. Okay, there's just f prime and there's just y prime. Okay, those are all kind of the same. So if you're given an equation and you're asked to find like y prime, it means the derivative of y. That's what it means. Now this other notation here, differential notation, gets used a lot too, and so you want to be really familiar with it. All these things also mean the derivative of f or of y. Okay, so they're the same they're different notations, but they mean the same thing. So you see df over dx, dy over dx, d over dx of f of x. The d is actually, it used to be a delta back in the day. It's kind of morphed into us just writing d. What does delta mean in science all the time? Change. So when you see something like dy over dx, which is the most common way, this one in the middle is the one you'll see the most, dy over dx. What it means is it means change in y over change in x, which is what? What's change in y over change in x? Slope, which is what a derivative is. Okay, so that's why we use this notation. This notation really makes good sense when you think of what a derivative actually is. The other nice thing about it is that it's clearer than the f prime or y prime because it always tells you what you're taking the derivative in terms of. It's always in terms of x. So that's what dy over dx means. It's telling you we're looking at the change in y in relation to the change in x. Okay, whereas if you just say y prime, you don't necessarily know what you're looking at there. So all these notations are going to be used. They all mean the exact same thing. We'll kind of talk about them a bit as we go through, but just kind of like when you look at them, know that they all mean derivative. Okay, there's nothing else to it there. Okay, and now we're going to look at a couple more multiple choice, and then we'll have some time to look at your practice tests. Okay, I'm just going to skip to some more questions. Okay, so here, if x squared minus 9 is made continuous by filling in the removable discontinuity at x equals negative 3, then f of negative 3 is... Hey, it's later on. It's like slide, I don't know. Has someone found it? 17. Cool. Yeah, it's later on because we'll come back to this other stuff. I want to have enough time to actually look at these questions. Okay, so try doing this one. This is one that I think people should be able to do. I would hope that people would be able to do this one. So you're trying to find the y value of the removable discontinuity here. That's what it wants you to do. Yeah, I'm just going to give you like 1 minute. Yeah, it's pretty easy if you know what you're doing, it's easy. If you don't know what you're doing, it's not.
Oh, I got it wrong. Oh, so easy, so easy.
Haley, you don't need to rub it in so much. That table's mean. Yeah, you should avoid them. Yeah. Cyrus thinks you're mean. That's what he just said. Okay, who thinks they know the answer? Lord, what do you think it is? D. Does everyone agree with her? Does anyone not agree with her? Does anyone want to go to the mat that it's not D? It is D. What Conrad, what did you think it was?
Well,
I'm just interested. Huh?
I had negative 3.
Oh, you're negative 3. So you accidentally put 0 in instead of negative 3 or something?
No, I was doing something different.
Okay, he was just doing something totally different. So what you should have done is looked at the limit of this graph as x approaches negative 3, or you don't even really have to formally look at the limit. You can just factor the top. That's x plus 3, x minus 3. So the x plus 3's cancel, and you plug negative 3 in, you get negative 6. Okay, that's how you do that one. Okay, so it's just canceling off what can cancel, and then plugging in the number. That's it. Pretty straightforward. Now, let's look at the second question on that page. Let f be the function given by this. This is actually a very similar kind of question. For what values of a is f, but harder, obviously. For what values of a is f continuous at for all real values? So I want you to think about that for a minute. Oh, I think there's supposed to be choices here, maybe. Or maybe not, I'm not sure.
How many values of A? What if there's 7?
No, I think it means like 1. Like A equals 1. No, I feel like this, well, I don't know. I'm actually gonna like take off the answers here. I don't feel like any of these are right.
The only one below.
Hey, does anyone think they know when, for what values of A? I think there might have been options. Okay, I think there might have been like some options written out before, and now they're gone. Here, okay, let's just imagine this. Like, did anyone? I'm sure some people thought it would be D. I don't know, maybe. Maybe somebody thought it might be D. If I had A as 4, if I put 4 in for A, here, what would happen? So I'd have x minus 1 over x squared minus 4 over x squared minus 4. What would happen? It would cancel. Does that mean that now it's continuous at 4? No. It just means that it has what type of discontinuity? Right, it has removable discontinuities at those zeros. So that actually wouldn't make it continuous. But there are certain values here of A that would make this graph continuous all the time. There's a certain thing that you could put in for A that would mean that there would be no non-permissibles. What kind of number could I put in for A here that would leave this with no non-permissibles? There's a lot of correct answers. 3. No, 3 wouldn't work because if it was 3, if I had x squared minus 3 on the bottom, I would have non-permissibles at positive and negative root 3. Okay, so 3 wouldn't work. Sorry? A negative number. If I had any negative number at all, like let's imagine negative 1, x squared minus negative 1 is x squared plus 1. There are no zeros on that graph. Okay? Nothing, x squared plus 1 has no possible zeros because x squared is always positive and plus 1 would make it continue to be positive. So any positive number at all oh, sorry, yep. I was just thinking that it had to be positive, but it's because it's already minus. So any negative number, and that would make this graph be continuous. So A must be less than 0. Okay, and it would make it work. So that's not one of the answers there. I don't know. I feel like there's something wrong with that question. Maybe none. I mean, none of those are right. If it was like none of the above. Which actually maybe was what the question was supposed to say. It was maybe supposed to be like 1, 2, 4, or none of the above. But just being aware, like, I think what the question is trying to get at is that canceling off something does not mean that the graph is now continuous there. It means that there's a removable discontinuity there. The only way for it to be continuous is if there's no non-permissible values at all. Okay, so I think that's the point of that question. I'm going to go in and change it so next time it's not like that. Okay, let's just look at a couple of these graph questions because they're pretty easy. So everyone try to answer this right now. So it wants to know which of the following is true. And just to be clear on the test, all the multiple choices will have one answer. Okay?
Oh, I did.
I think I did.
A couple people did. If you did it, you weren't the only one.
Wait, Callie, is this stuff on our test tomorrow?
Yes.
On Friday.
Like this is limits.
Oh, okay. I see.
This is just limits. So this is just limits review. You won't be asked to find the derivative on your test. Okay, some people think they know what it is. I hear. This is a quick one because it's just looking at the picture. What's the right answer here? D? Did people say?
Yes.
Yeah, that one looks correct. So it must be D. Okay, so the limit as x approaches b from the left and from the right are not the same, so the limit does not exist. So that is why. There we go. Easy enough. So it's not 1, obviously it's not 2. It just doesn't exist. So that one was pretty easy. Questions. Hopefully everyone, I think everyone kind of gets them at this point. Like it seems like everybody does. People did fairly well with them on the quiz. Okay. Now here, on which intervals is f continuous? So answer that one. I think this one was on your practice test. Maybe. No, maybe not. It was just the same graph, I think. Lauren's never seen this graph before. Hey, what's the answer here? It is B. Okay, that's the only one that has, the important thing here is that these symbols are all less than or equal to, which means that the endpoint would have to be continuous as well. So if I look from -1 to 0, the endpoint here is not continuous. I would have to jump down to be here, down at the bottom. But on this one it is, because it starts there, it goes all the way up here, and it finishes. So that one's continuous. The other ones aren't, because there's a hole at both ends on the 1 to 2, and there's a hole at 2 to 3 as well. Okay, so the only segment here is 0 to 1. If I said -1 is less than x is less than 0, that would be fine. Okay, it would be fine, but I didn't say that, so it's B.
If there were a filled-in dot at 1,
Then it would be,
okay.
yeah. But it also wouldn't be a function, because there would be, it wouldn't pass the vertical line test if that was filled in. So, okay, so that again, I think is a fairly easy question, maybe a little tricky if you're not really sure about continuity. Let's just look at one more. This is a tougher one, I think. Okay, see if you can figure this one out. Okay, see if you can get the right answer. Give yourself a second.
So there's a point there, but it's not seen as part of the graph.
It's like, oh, it is where it is, though. It's not 0, so technically it's a straight line. I'm pretty sure that is a
Okay, so what do people think? Okay, so the question here about whether or not it has a removable discontinuity is whether or not this value here, the 0, as x equals 0, would plug our discontinuity. Okay, because if it is at the point of our removable discontinuity, it would fill the removable discontinuity and we would have a continuous graph. That's the question, is does that 0 fill our hole? So what you want to do is you want to look at the limit of x approaches 0 of x squared over x. Now, what is x squared over x? X. So the limit of x approaches 0 of x is 0, which means that our removable discontinuity of this part is at 0, 0. So this second graph fills that hole. So what that would mean is that like our original graph would look like this, like the top graph would look like this, and it would have a hole at 0. And then we would fill that hole in, and we would have one straight line. So this graph is actually continuous everywhere. Did anyone get that? Now, one of the problems with picking C is that B and C would both be true if you thought that. Like, because actually B, C, and D would all be true. Like, if C is true, B is also true. Like, that's what you'd have to realize. Because if we're saying it has a removable discontinuity, that would mean that it's continuous everywhere except there. And if it had an infinite discontinuity, it would be continuous everywhere except there. So you can't pick C or D. It just doesn't make sense for C or D to be the answer, because then B would also have to be an acceptable answer. So this question is actually kind of a bad question, because you could just logic out that the only possible answer for there to be is A. But you'd have to really kind of think about it. So, that doesn't happen too much. Okay. But do try to remember, like with removable discontinuities, when you have a piecewise function, sometimes those things are filled. If this value had not been 0, if this value had been, 5, right? Then this graph would not be continuous. Because instead of having that hole filled, I would have a point up at 5. Okay, so the point of it is that 0 is there. Okay, so that